Hello there and welcome for today's lesson involving linear relationships. In our previous lesson, we discussed how you can be able to find the equation of straight lines. In today's lesson, we want to use that concept of equation of straight lines to determine the gradient of the straight line. You may remember that we expressed equation of the straight line in the form y is equal to mx plus c. That is, we did not go further and elaborate the significance or the specific significance of the constants m and the constant c. We only mentioned that x and y are variables. We did also mention that m and c are constants, but we did not go further and significantly tell the meaning of m and c. So in today's lesson, we shall be able to understand what m represents and what c represents as a constant. Now, before we go to that detail, we shall be able to define the meaning of gradient of a line. Gradient of a line is simply defined as the measure of the steepness of the slope. The measure of the slope of any straight line is the gradient of that particular line. Now, how do we determine the gradient of a line or the steepness of a line? First of all, we need to know that at one point in life you can climb a hill or you can or a valley. You can be able to go down a valley. There are hills which you can climb very comfortably and easily within the shortest time possible. However, we have other cases where the hill is very steep or the mountain is steep and therefore you cannot be able to climb as fast as you may do when you are climbing a hill that whose slope is a bit less steep. So we shall be able to understand how to calculate the steepness of a slope. And it's important for us to consider this case. In case 1, we are having a straight line . The line is joined by 2 points. The points are represented with a dot. So how do you calculate the steepness of that particular straight line? It's important to understand that to calculate the steepness of the line, we shall consider how far the point has moved horizontally, and that is called a run. So a run implies the distance between 2 points horizontally. That is the distance between 2 points on a straight line horizontally. In our case, our run is positive and the run is always positive. It always moves from the left to the right and therefore assigned a positive sign convention. we shall also consider another component, that is the vertical component of our line. And the vertical component is called a rise. So a rise by definition is the distance between 2 points vertically. So in our case, our rise is positive because the movement is upwards. So when the movement is upwards, the rise is positive. To calculate the gradient, we shall apply the formula rise divided by the run. In case 1, the rise is positive. In case 2, in still case 1, the run is also positive. That is the horizontal distance between 2 points. If we take a positive value divided by a positive value, the result is positive. So this implies that the gradient for case 1 is positive. And if we study the nature of the line is running from negative side, or from the left and running vertical to the right. So if the line runs from left to right, then that is a positive gradient. That gives us a positive gradient. Why? Because the rise is positive and the run is also positive. And remember, as I mentioned, the run is always positive. That is the horizontal distance between 2 points is always considered positive, while the rise can either be positive or negative. Let us now proceed and consider case 2. In case 2, we are again having our straight line. Our line is running from left to the right, but downwards. And therefore, in this case, we shall consider the horizontal movement of the point we are moving from point 1 to point 2. But remember, in our first case, we were moving from, again, point 1 to point 2. But point 1 was on the left, point 2 on the right. The rise, there was an increase in y component and also an increase in the x component. In our second case, the horizontal component is still towards the right. So our run is still positive. So this is called the run. It's positive. However, our rise is not positive. Our rise in this case is negative. Therefore, how do you calculate the gradient of the line from P1, point P1 to point P2? So we apply the formula gradient or slope is obtained by taking the rise divided by the run. In our case, the rise is negative, while the run is always considered positive. So it is important for us to understand the sign convention so that we can be able to understand the nature of the gradient for each specific line. So in this case, if we divide a negative value by a positive value, the result is negative. And therefore, we can be able to conclude that the gradient of this line, which is sloping downwards, is negative. Now, the gradient is negative because the y values are decreasing from the first point to the next point. From point 1 to point 2, the y values are decreasing. If we just go back slightly and look at case 1, the y values were increasing as we move from point 1 to point 2. But in the second case, the y values are decreasing as we move from point 1 to point 2. And since the y values are decreasing, we can therefore say that the gradient is negative. Let us proceed and discuss this case 3, which is representing a vertical line. When the line is vertical, then there is a rise. The rise is existing. However, the run is not there. We don't have horizontal movement. So the run is 0. Therefore, if we calculate the gradient of such a line, you will discover that the rise is existing while the run is not existing. There is no horizontal movement. And therefore, we assign that with a 0 because there is no movement. So a 0 in this case implies there is no movement. There is no change between the 2 points. There is no change. Therefore, if we take a rise divided by a 0, you find that the result is undefined. Why is it undefined? It is undefined because if we take any value, suppose we say a rise is 1, and we say a run is a value which is very close to 0. We can start with a value like 0.01. This value is very close to 0 if we round off to one decimal place. So the gradient will be given by taking the rise divided by the run. In this case, 1 divided by 0.01, and that gives us 100. Suppose we increase our value, we reduce our run further so that it tends to 0. If our value is for the run tends to 0, what happens is the value of gradient increases. And you find that the value of our gradient is very large. So if we continue reducing the value of the run, it means the gradient will continue being very large and large and large. And therefore, such a gradient for a vertical line, we say it is undefined. So we can be able to confidently say that for any vertical line, its gradient is undefined. Lastly, we consider a horizontal line as our case 4. So in our case 4, we are having a horizontal line. The horizontal line is drawn as follows. So the coordinates of the first point is x1, y1. The coordinate for the second point, P2, is x2, y2. But because the line is horizontal, it means the y value is constant. It is not changing. Therefore, the y value is 0. So instead of y1, I replace that with a 0. So in this case, the y values are not changing. It's constant. However, the x value is changing from x1 as we move from point 1 to point 2, and the x value for point 2 is x2. So how do you calculate the gradient? Gradient is obtained by taking the gradient is calculated by taking the rise divided by the run. In this case, the rise is the change in the vertical distance. In this case, we can take 0 minus 0. Because there is no change in the rise, it's a horizontal line, then we say the rise is 0. No change in the rise. The rise is 0. But there is change in the run. And we said the run is always positive. So in this case, it will be x2 minus x1. So if you take a 0, divide by any value, the result is a 0. Therefore, we can confidently say that for all horizontal lines, the gradient is 0. So we can say that the gradient of horizontal line is 0. So basically, we are going to summarize in a Cartesian plane the types of gradient that we have. The first type of gradient is positive gradient. We can illustrate a positive gradient as shown. The second type of gradient is called negative gradient. We can illustrate the negative gradient as shown. In that case, the y values decreases from left to right, while for positive gradient, the y values increases from left to right. The third type of gradient is the zero gradient. For zero gradient is just a horizontal line. The last type of gradient is undefined gradient. For undefined gradient, we represent it using a vertical line. Now, we can be able to put this summary on a Cartesian plane as follows. If the gradient is positive, if we consider our line passing through the origin and the gradient is positive, okay, if we consider a line passing through the origin and running from the lower side of the Cartesian plane, rising all along to the right, then its gradient is positive because there is an increase in y values. However, if we consider a line where the y values are decreasing, like in this case, line 2, the y values are decreasing, its gradient is negative. Suppose we have another line which is horizontal and parallel to x-axis. This line, line 3, is horizontal and parallel to x-axis. Its gradient is 0. If we consider a line that is vertical and parallel to y-axis, in our case is line 4. Its gradient is undefined. And therefore, we have summarized the type of gradient on a Cartesian plane. Now next, we want to look at illustrations or examples on how we can find the gradient of a line. Now, to find the gradient of any line, Suppose we consider a line that is cutting the x-axis at -1 and cutting the y-axis at +2. The first step we need to do is to identify the points on that particular line. Identify any 2 points. So the 2 points here have indicated using a dot. The first point is P1, while the second point is P2. For point P1, we are supposed to get the x-coordinate and the corresponding y-coordinate. For point 2, we are also supposed to get the x-coordinate and the corresponding y-coordinate. The x-coordinate for point 2 is x2. In this case, we are using that notation, and the y-coordinate is point y2. Now, what is the coordinate of point P1? I believe you have noticed that the coordinate of P1, first of all, is a point where the graph is cutting the y-axis, and therefore the x-coordinate is 0. The y-coordinate is 2. So our point P1 is 0, 2. However, for our point P2, the x-coordinate is -1, while the y-coordinate is 0 because the graph is cutting the x-axis. Now, having identified the 2 points, point P1 as 0, 2, while point P2 as -1, 0, we can be able to calculate the gradient of the straight line. By applying our initial formula, rise over the run. Now, for the rise here, we shall take a difference in the y-coordinates, y2 minus y1, divided by the difference in the x-coordinate, that is x2 minus x1. So our y2 in this case is 0. Our y1 is 2. Our x2 is -1. Our x1 is 0. So the result is as follows. -2 divided by -1 gives us 2. That means the gradient of this line we have drawn is 2. And just by looking at it, you will be able to confirm that the gradient is 2 just by inspection, because the y values are increasing from 0 as you move upwards to 2. So therefore the gradient is positive. Let us consider another example. In our example 2, we have a graph which is cutting the y-axis at 3 and cutting the x-axis at 2. So the first step in calculating the gradient is identification of the points. Identify 2 points that lies on the line. The x-coordinate is 3. Sorry. The x-coordinate at the point where the graph cuts the y-axis is 0, while the y-coordinate is 3. The x-coordinate where the graph cuts the x-axis is 2. While the y-coordinate where the graph is cutting the x-axis is 0. That means that our y1 is 3, our x1 is 0. Our x2 is 2, our y2 is 0. From the formula of calculating gradient, we realize that gradient is given by a rise divided by a run. In this case, the rise is obtained by subtracting the points on the vertical component. In this case, y2 minus y1. That means the second y-coordinate minus the first y-coordinate. Divide by the corresponding x-coordinate, second x-coordinate, minus the corresponding first x-coordinate. If we substitute in the values, y2 is 0. So we take y2, which is a 0, y1, which is 3, minus y1, x2, which is 2, and x1, which is 0. So that gives us negative 3 over 2. So it's important for us to note that by just inspection, you discover that actually this particular line has a negative gradient because the y values are decreasing from 0 to 3. It's important to note that when writing the gradient, you can either express it as a proper simplified fraction or improper fraction. but never express gradient as a mixed fraction. So in our example 3, we want to find out how we can be able to find the gradient of a horizontal line. So first of all, we define the equation of this horizontal line. The equation of the horizontal line is y is equal to 4. And we said that the gradient of horizontal line, you don't need to calculate. The gradient of horizontal line is a 0. The gradient is 0 because there is no rise for a horizontal line. The rise is 0. However, the run is there. And if you take a 0 divided by any value, the result is 0. So, because the line y is equal to 4 is a horizontal line, its gradient is 0. So the reason we give is that you say the gradient of a horizontal line is 0. So in example 4, we want to look at gradient of a vertical line. So our vertical line is line x is equal to 2. The gradient of any vertical line parallel to the y-axis, we mentioned earlier, that is 0. So again, you don't need to calculate this. Is undefined. So you don't need to calculate the gradient of a vertical line, but you just use the descriptive part of it. The gradient of a vertical line is 0, is undefined. The gradient of a vertical line is undefined. Sometimes we use this symbol. So we want to find out how we can find the gradient between 2 points. So point 1 is 3, 4. Point 2 is 5, 6. Now, for the start, we can be able to represent the 2 points on a Cartesian plane. But later on, with a lot of practice, we shall be able to calculate this gradient without necessarily representing on a Cartesian plane. So the first point is 3, 4. Then the second point is 5, 6. So we join the 2 points using a straight line. Now, we introduce a right-angled triangle, or we create a right-angled triangle where the vertical distance between the 2 points is called the rise, while the horizontal distance between the 2 points is called the run. So the run is obtained by getting the difference between the x coordinates between the 2 points. The first x coordinate, suppose we call it x1. The first y coordinate is y1. The second x coordinate is x2. And the second y coordinate is y2. Now, to get the rise, we take y2 minus y1. That is, subtract the y coordinates. Divide by the difference between the corresponding x coordinates. In this case, x2 minus x1. Our y2 as a point is 6. Minus y1 is 4. x2 is 5. While x1 is 3. So the result is 2 divided by 2, which gives us 1. Why? 6 minus 4 is 2. 5 minus 3 is 2. When we divide 2 by 2, the result is 1. And therefore, the gradient of the straight line given is 1. So that is how we find the gradient between 2 points, as illustrated in this particular example. Now, let us consider example 2, where the first point, P1, is 1, negative 3, and the second point, P2, is negative 3, 6. So to start with, we can represent the 2 points on a Cartesian plane just by a sketch. The first point is 1, negative 3. The second point is negative 3, 6. Then we join the 2 points. Once we join the 2 points, we obtain a straight line. So we can be able to find the run, which is the horizontal distance between the 2 points, by introducing or creating a right-angled triangle. So the run is the horizontal component, while the rise is the vertical component. In this case, the rise is dropping, so there is a drop, while the run is always positive. So our rise will be negative, while our run is just positive. Now, to get the gradient, we find the rise, we get the rise divided by the run. The rise is y2 minus y1. While the run is x2 minus x1. Our y2 is 6 minus our y1 is negative 3. Our x2 is negative 3 minus our x1 is 1. So 6 minus minus 3 is the same as 9, because minus minus gives us positive. So the gradient of the line is 9 divided by negative 4, which can as well be written as so we can write that as negative 9 over 4 because the rise is negative in this case and the run is positive. As I mentioned, the run is always positive. So you assign the negative sign on the numerator part. So the gradient can either be expressed as a proper simplified fraction or improper fraction, but should never be expressed as a mixed fraction. So I've given one question here as an exercise. Find the gradient of the lines joining the following pairs of points. In our first question, the point A is 2, 3, and point B is 3, 5. So in this case, having done representation on the Cartesian plane, we don't need to go that far. But the only thing we do is to apply our formula. We apply the formula, gradient is rise over run. And the rise is y2 minus y1 because that is the distance between 2 points vertically. Then the run is x2 minus x1 because it's the distance between 2 points horizontally. So in our point A, we assign x1 for x coordinate and y1 for the y coordinate. In our point B, we assign x2 for the x coordinate and y2 for the y coordinate. So, after assigning, we now substitute. y2 is 5 minus y1 is 3. x2 is 3 and x1 is 2. Then we simplify the numerator first. 5 minus 3 is equivalent to 2. Then for the denominator part, we have 3 minus 2, and the result is 1. So finally, the gradient between the 2 points A and B is 2 divided by 1, which is equivalent to 2. So that is how we can find the gradient of any given straight line passing through any given points. So in summary, we are saying the major thing is to understand the formula. Gradient is given by rise over run. Then we need to know that the rise can either be positive or negative, but the run, which is the horizontal distance between the 2 points, is always positive. Then it's also very important to know that the gradient is either expressed as a proper fraction or as a proper simplified fraction or as an improper fraction, but should never be expressed as a mixed fraction. That is the end of our lesson. Thank you.